or race around condition which is occurred at the last term condition where J, K both are equal to 1, 1 and unable is 1. Okay, in that case, toggling condition is occurred or the race around condition is occurred. And in the previous lecture, we have already seen that how to avoid the race around condition. Can anyone tell me how to avoid it? Yes. Two circuits are given to avoid the toggling condition or the race around condition. First one, first one is age triggered JK flip flop. Means when you use, yes, using ages. When you use age triggered JK flip flop, we can avoid the toggling condition because uh, for age triggered flip flop, that flip flop will respond only for either positive age or the negative age, and the age is available for very short period. That's why whenever the output toggle, the age is reaches to the highest level, that is level 0 or level 1. Okay, then no toggling is occurred in that case when you are using age triggered method or age triggering flip flop. And the second one circuit is what? The master slave JK flip flop. With the help of master slave JK flip flop, we can avoid the toggling stage or the race around condition. Now we'll see the circuit diagram of master slave JK flip flop. This is the circuit diagram of master slave JK flip flop. It consists of two different flip flops. This one is called, suppose this is the JK flip flop and the second one is the SR flip flop. Okay, means the master slave JK flip flop circuit consists of two different flip flops. First one is JK flip flop and second one is SR flip flop. SR flip flop work as slave and JK flip flop work as master flip flop. That's why it is called as master slave JK flip flop. Master slave JK flip flop. Where JK flip flop is used as master and SR flip flop is used as slave. Okay, slave flip flop. Now we'll see how the toggling or the race around condition is avoided by such a circuit. We'll see first. Suppose toggling or race around condition occurs when J, K and unable to be equal to 1. For such a condition only, race around condition or the toggling condition occurs. So we'll see first, suppose unable. Both flip flops are label trigger flip flop. Means first flip flop, just see this circuit. This circuit has first one is the JK flip flop and second one is the SR flip flop. In the JK flip flop, both JK and SR both are label trigger. Means that particular flip flop respond for logic 0 and logic 1, not for age. Okay. Means what? Two methods are there to avoid toggling condition or the race around condition. First, we have already seen that is age triggered flip flop. With the help of age triggered JK flip flop, we can avoid the toggling or the race around condition. The second one condition is what? If you want to use label trigger, in that case, you can use master slave JK flip flop to avoid such a condition. These two flip flops, JK and SR, both are label trigger flip flop. Means these flip flops respond to only logic 0 or logic 1. This is the first JK flip flop where we are passing clock signal as it is. Clock signal as it is. Means this is positive label trigger. Label triggered flip flop. Okay. Means JK flip flop is positive label triggered flip flop, and for SR flip flop, the clock is connected to NOT gate. To NOT gate means what? Whenever suppose unable is equal to 1 and we are passing this unable to JK flip flop and simultaneously to the SR flip flop. Okay. But if E is equal to 1, then the clock signal for 0 because the clock signal is connected to SR through NOT gate. Okay, this is the NOT gate provided here. Means what? If enable is equal to 1, then the clock signal to SR flip flop becomes 0. If enable is equal to 0, then SR flip flop clock signal becomes 1. Means at a time only one flip flop is in working condition. Understood? Means what? This complete master slave JK flip flop uses positive label triggered flip flop. Means both SR and JK flip flop both are positive label triggered flip flop. Means the JK flip flop will respond, will change their output only it gets the positive label at the clock signal. Similarly, SR flip flop will respond to the input combination only when it gets the positive label, that is at the clock signal means what? 1. Logic 1. For logic 1 it will respond and it will change their output. And just see output of SR flip flop. The negative output with the complemented output of SR flip flop is connected to the input of J, and Qn is connected to the input of K in the JK flip flop. Okay, this is the circuit diagram of master slave JK flip flop. We see first condition where J, K and E both are all values are 1. Here J is equal to 1, then K is enable also equal to 1. Initially enable and K both are equal to 1. Then it is dependent upon the previous value Q and Qn. Qn and Qn complement. It is totally dependent upon this. Means when enable is equal to 1, then the output of JK flip flop changes, but at the same time enable is connected to NOT gate to the SR flip flop, means SR becomes 0. SR becomes 0 means it is in the deactivated condition. Okay, it is not activated, it is not enable, it is disabled. Means what? Whatever the previous output of SR flip flop which is given as input here. Understood? Suppose Qn is equal to 1, then Qn complement becomes 0. These are the outputs of the previous state, not the current state or not the next state. And we are going to find out the output of next state. So previously Qn and Qn complement was 1 and 0. Then this 0 is given as input to J. So J output of this NAND gate, output of this NAND gate will be 1 because if one of the input is 0, then output becomes 1. And this Qn is given as input to K. Suppose means what? All three inputs are 1, so output becomes 1. Sorry, 0. And this 0 is given to these two NAND gates. Again, Qn, Q1 and Qn plus 1 intermediate outputs are given. And suppose intermediate, this 1 is there and 0 is there. No matter what was the previous output Q1 and Q1 complement, if one of the input is 0, then output is always 1. Output is always 1. This 1 is there and then this 1 is connected here, so output becomes 0. Okay, so here Q1 is 0 and Q1 complement becomes 1. And that Q1 is given as input to S value. Okay. But here the output of JK flip flop toggles one time. Toggles one time. It remains toggle continuously till you get the label 1. Okay. But the output of this one means Q1 is connected to input of S and Q1 complement connected to input of this R for the SR complement. Then, but here clock signal is at 0 level. That's what this particular SR flip flop is deactivated. It is disabled. Means it will not change their output. So no matter the execution is stopped here. Okay, means no toggling is occurred. Understood? Otherwise, if suppose here you are passing enable value 0 to J flip flop. Enable value 0. Yes, now is it okay? Now is it visible? Is it visible now? Okay. So when you pass clock signal to JK flip flop 0, then in that case JK flip flop is in disable condition, and if enable is 0, then complement of enable becomes 1, and it is given as clock signal to SR flip flop. So now SR flip flop is in working condition, means it will change their output as per the combination of input variable, where it will just respond. Means what? Suppose initially this Q1 was 0 and Q1 complement was 1, which is given as input to S and R. So now S value is 0 and value is 1. And whatever the value of enable value is 1, 1. So both 1, 1 inputs are there, so output becomes 0. If one of the input is 0, the output becomes 1. And which is given as the next NAND gate input means 1, 1 there. Okay? Sorry, 1, 0. If one of the input is 0, then output becomes 1, and this one is 0. Both are 1, 1. This one is given as input, so output becomes 1. Initially, Q1 was 1 and Qn complement was 0. Now, for the next clock pulse, Qn becomes 0 and Qn complement becomes 1. Means now it will toggle one time, single time. But what happens when you take this output to JK flip flop? Means what? This 0 is connected to K point, and this 1 is connected to J input. But now enable is equal to 0. For the same time, enable is 0 for JK flip flop, means what? The JK will not respond. It is in the disable condition. So no matter the output are given as input to JK flip flop. Okay, means in the both cases for JK and for SR flip flop, output will changes only one time. It will not toggle continuously. Why you are using master slave JK flip flop? Because at a time, not both flip flops are in working condition simultaneously. At a time, only one flip flop is in working condition. So output of the first one flip flop, means SR flip flop, is given as input to the JK flip flop. But it is not in a working condition right now. That's why no matter, means the JK flip flop will not changes their output, which is given as input to the SR flip flop. Okay. So here only one for one clock signal, it is SR flip flop will changes only one time, from 0 to 1 or 1 to 0. Understood? That's why we can avoid the toggling condition, or we can avoid the rest around condition with the help of master slave JK flip flop. Yes, all of you understood? So draw this diagram. As I have already explained how to avoid rest around condition just by using two. Yes, what Kanaya asked. Yes, flip-flops are connected to each other. Flip-flops are connected to each other. Okay, but just see, when I'm passing clock signal, that is the label trigger. I'm using label trigger both SR and JK flip-flop. But suppose here I'm passing clock 0 initially. This is my clock signal. Okay, initially I'm passing 0. Initially I'm passing only this component. This component to my circuit. Okay, for this component, JK flip-flop is disabled and SR flip-flop is in working condition. Means it is unable. It will change their output. Okay, but suppose at this point, I am giving 0 continuously till this time period. Output of SR flip-flop will change. Okay, but this output of SR flip-flop is given as input to JK flip-flop at the same time. Suppose at time t0 and 0. So for time t is equal to 1. For time t0, SR changes the output. Okay, that output is given as input to JK flip-flop. Now, right now, I am at time t is equal to 1. But in that case, JK flip-flop is having enable 0, means negative label we are passing as clock signal for JK flip-flop. But JK flip-flop is visible because it is a positive level trigger flip-flop. So JK flip-flop will not change their output, will not respond for the input. Okay, so Q and Q1 was same as the previous one. That's why the Qn and Qn complement will not toggle in such a case. Understood? And if I am giving and passing enable is equal to 1, means here, if my clock pulse is at this position, means here, okay? And here in this case, JK flip-flop is in working condition because it is positive level trigger, it will only respond for positive. So it changes the output, that is Q1 and Q1 complement becomes 0, 1, and which is given as input to SI for the SR complement. At time, suppose at time T1, the output of Q1 and Q1 complement generates T is equal to 1, generates Q1 is equal to 0, and Q1 complement becomes 1. But at the same time T is equal to 1, clock signal is given to SR flip-flop is equal to 0 because T is equal to 1, which is connected to not yet. In that case, SR flip-flop is visible. It is not in a working condition. So no matter what value, the toggle outputs Q1 and Q1 complement, the toggle outputs is given as to SR flip-flop, but SR flip-flop is not in the working condition, so SR will not changes their output at the same time. Okay, until we reach to the last point of the logic 1. Okay, and now again we get the negative age. In that case, the negative age, both flip-flops are in the disable condition. Means both flip-flops will not respond for the negative age and for the positive age. It will only respond for the logic 1. Understood? Yes, Kanaya, are you getting this? Okay. So just complete this diagram. Is done? Completed? Okay. So now we'll see the next concept, that is preset and clear input. Every time when you want to know the operations and what will be the next state for the input combinations, every time we should assume the previous state output Qn to get Qn plus 1. Okay, but when we start flip-flop circuit, initially we don't know the previous output values of Q and Q complement. We are just assuming what was the value of previous state Qn and Qn plus 1, Qn complement. Okay, in some application, it is necessary to initially set or reset the flip-flop. In some applications, we should have the input previous state output either 0 or 1. Means as per our convenience, we should have the input values, previous state output values, either 0 or 1 Qn and Qn complement. For such a condition, this can be done by adding 2 more inputs to the flip-flop are called as preset and the clear inputs. So we'll see the preset and clear inputs added into the JK flip-flop. The symbol table of JK flip-flop will look like this. Suppose this is the JK flip-flop. JK flip-flop is having three inputs J, K and unable, and output will be Q and complement. Okay, so instead of these inputs and outputs, we can add two inputs here. That is, first one is reset and second one is clear. Second one is clear. Okay. So let's see the truth table of such a flip-flop. It is having two additional inputs, preset and clear. Initially, suppose clock means unable. Suppose preset and clear inputs are there. Okay. So initially, if this unable value or the clock signal is either 0 or 1, then 0, 0, 0, 1, 1, 0 and 1, 1 irrespective of the clock signal. Or here in this case, if unable is equal to 1, then what will be the value of output? Output can be, initially output can be read for first condition. Okay, here for we say output can be 0, or we say output can be 1, and here also the avoidable condition or the normal condition where we can get the output, that is Qn plus 1. Okay, this is the truth table of JK flip-flop when we are using the additional inputs, that is preset and the clear input. Sorry. 1 and 0. Here, flip-flop is in state. And here, flip-flop is in reset state. Yes, completed. Means when you want to say your flip-flop, then you have to connect reset and clear to 0 and 1 respectively. If you want to reset your flip-flop, then you have to connect reset and clear inputs to 1 and 0 respectively. Okay, and if you are connecting these to 1, 1, then your flip-flop will work as a normal flip-flop. At that time, you will get the Qn plus 1 by assuming the previous state output Qn. Okay. So after this, we'll see the next concept, that is counter. Counter is also one of the example of sequential circuit. It is a digital sequential circuit that is used to count the number of clock pulses. Whenever I'm saying the clock pulse is given to your circuit, but how much clock pulse you are giving to your circuit, the purpose of this to count that particular clock pulses, counters are going to use. Counter is one of the example of sequential circuit. Okay, then the counters are of two different types: asynchronous counter and the synchronous counter. Asynchronous counter, it is also called as the ripple counter. Just write down, make a note. Counter is also counter has two different types: synchronous counter and asynchronous counter. Asynchronous counter is also called as the ripple counter. Okay, and counter is used. Flip-flop. Just tell me, flip-flop can store how many bits? Just tell me, one single flip-flop can store how many bits? Yes? Priyanka, Chetna, Akshada, Ishika, yes, Prathamesh. 2. Priyanka Vidate. Flip-flop is also called as memory unit. It is also called as cross-coupled structure. Okay, the flip-flop can be stored only one single bit. Okay, so we'll see asynchronous or the ripple counter first. We'll see directly the diagram of 2-bit asynchronous binary counter. 2-bit asynchronous counter. We'll see first asynchronous counter. It is also called as ripple counter. It is also called as ripple counter. Single flip-flop can store single bit, single binary bit, either 0 or 1. Okay. Asynchronous counter is also divided into 2 different types. First one is asynchronous up counter. Asynchronous up counter. And second one is asynchronous down counter. Down counter. Okay. So we'll see first asynchronous up counter. The name suggests up means if you want to count the clock signals in the ascending order, then you can use asynchronous up counter. And if you want to count the clock signal or clock pulses in the downward direction, means descending order, then you should use asynchronous down counter. Yes, all of you getting these two concepts? Asynchronous up counter and asynchronous down counter. Let's see first the difference between asynchronous counter and synchronous counter first. This is the asynchronous counter. When suppose you want to design 2-bit asynchronous and 2-bit synchronous counter. Okay. So first we'll see 2-bit asynchronous counter and 2-bit synchronous counter. Okay. For 2-bit, we should use 2 flip-flops. Okay, to store 2-bit, we should use 2 flip-flops. Here I am using C flip-flop right now, or JKB flip-flop. Suppose I am using JK flip-flop. Okay, JK flip-flop. First one JK flip-flop and second JK flip-flop. Second and first. Okay, and here clock signal means enable as clock signal CLK. Okay, and then outputs are generated. Suppose this one is A and this one is B. So QA and QA complement. Outputs can be QB and QB complement. QB complement. If clock signal, the external clock signal is connected to flip-flop A. Okay, and output of flip-flop A is connected to the clock signal of the next flip-flop. Clock signal of the next flip-flop. Okay, then that particular counter is called as asynchronous counter. Understood? Means the external clock signal is given to the first JK flip-flop and output of this first one is given as clock input. This is the enable. Enable means C and K. Okay, and JK flip-flop. J and K means output of QA. Output of first flip-flop is given as clock signal input to the flip-flop B. Then that particular structure or counter is called as asynchronous counter. And we'll see how to design synchronous counter. Again, I want to design 2-bit synchronous counter here. So I should use 2 JK flip-flop. 2 JK flip-flop. Again here A and B. JK flip-flop A, JK flip-flop B. But in this case, J and K, again this is also having J and K. Output can be QB complement and QA complement. Okay, but in this case, only change is that external input should be applied to all the flip-flops, not the previous state output. External clock pulse is simultaneously given to each and every flip-flop. flip-flop, then that particular structure is known as a synchronous counter. This is 2-bit synchronous counter, and first one is 2-bit asynchronous counter, where the external clock pulse is given to only first flip-flop, and output of the previous flip-flop is given as clock signal to the second one, means the next flip-flop. In the case of asynchronous counter, and in the synchronous counter, clock signal, the external clock signal, simultaneously external clock signal is given to each and every flip-flop, then that particular counter is known as synchronous counter. All of you understood? Yes? All of you getting this concept? Because your next practical is based on this concept. Yes, understood? Okay. So, now we'll see the difference between up and down counter. Okay, we see first asynchronous up and asynchronous down counter. This is asynchronous 2-bit asynchronous up counter. When you connect QA to the clock pulse, QA to the clock pulse of BJK flip-flop, then it is called as 2-bit asynchronous up counter. Okay, now we'll see 2-bit asynchronous down counter. Instead of QA, if you connect QA complement to the clock signal of the second JK flip-flop, then it becomes 2-bit asynchronous down counter. When you connect the complemented output of the previous flip-flop to the next clock signal of the next flip-flop, then that particular circuit or the counter is called as down counter. Asynchronous down counter. Asynchronous means what? The external clock pulse is given to only first flip-flop. And what about the remaining flip-flops of the counter? For the remaining flip-flop clock pulses, the previous output of the previous flip-flop is given as clock signal to the next flip-flop. Okay, this is the asynchronous. And in the synchronous, external clock signal is given to each and every flip-flop simultaneously, then that particular circuit is known as synchronous counter. Here, these are the two different diagrams in this case. First one is 2-bit asynchronous up counter, where the external clock pulse is applied to only first JK flip-flop, and what about the second one JK flip-flop clock pulse? For this, previous state means the first JK flip-flop output is connected to the clock pulse of the second one flip-flop, then it becomes asynchronous. If you connect QA to the clock signal of the second JK flip-flop, then it becomes up counter, asynchronous up counter, and then you connect QA complement to the next flip-flop clock pulse, then it becomes asynchronous down counter. All of you understood the difference between asynchronous up and asynchronous down counter? Are you getting this? Yes? Okay. Okay. So, just draw this diagram. This is asynchronous down counter, where JK flip-flops are used. Now we'll see the circuit diagram of 3-bit asynchronous up counter. This is the problem definition from your assignment list. This is your 5th assignment from your assignment list. Design the asynchronous 3-bit asynchronous up and down counter using IC 7473. Okay. So first of all, we can see the circuit diagram of the same. Here, 3-bit asynchronous up counter. Either you can use JK flip-flop, T flip-flop, D flip-flop, you can use any type of flip-flop, but 7476 IC, 7476 IC is of dual JK flip-flop. Means for this assignment, you have to use this IC 7476, which consists of 2 JK flip-flops. So, for that purpose only, we should draw the circuit diagram having JK flip-flop. Okay. So here 3-bit or synchronous up counter you have to design. Means what? How many bits should be there? 3-bit means how many flip-flops you should use? Yes. How many flip-flops you should use? Yes. You should use 3 flip-flops. So use here first JK flip-flop, then second JK flip-flop, and then third one JK flip-flop. Or synchronous up counter. Or synchronous means clock signal is connected. External clock signal is connected to only first flip-flop. Okay. Suppose this is the A flip-flop, B and C flip-flop. Okay. This is J and K. J A, K A. Then again JB and KB and JC, JC and KC. Okay. And what about the next clock pulses? This one is the QA. So QA should be connected to the clock pulse of the B flip-flop. Again QB. What about QB? QB should connect it to the clock pulse of the C flip-flop. Then it becomes a synchronous up counter. It becomes a synchronous up counter. Then where you should connect this J and K, you should connect J and K to this system. All the J and K to this system. That is logic 1. Logic 1. You have to connect this. Yes, understood? This is the 3-bit or synchronous up counter. And if you want to use 2 more additional inputs, that is preset and clear, then you can use that. This suppose here this is the preset of the B and preset of the C. Then you should connect these two also with preset. And it is the clear. Again, you have to connect these inputs. This clear input of all 3 flip-flops again to VCC. Understood? This is the circuit diagram for 3-bit or synchronous up counter, where you have to connect the clock pulse, external clock pulse to A, and for the remaining flip-flops, you have to connect the previous output to the clock pulse of the next flip-flop. Yes, all of you getting this? So draw this diagram. Now mark your attendance in the chat box. Sequentially, roll number 1. Don't give randomly. Roll number 1, 2, 3, 4. 3 is absent, na? Okay. 4, 5, 6, 7, 8, 9, 10, 11. 10 is absent? Yes, 10 is absent. 12, 13, 14, 15, 16. 16 is there? Okay, 16 is absent. 17, 18, 19, 20. 19 is not there. 21, 22, 23, 24, 25. Don't send message individually to the respective faculty. If you are present, then just mark your attendance in the chat box. Your presently will not be considered when you contact your faculty personally. Okay? 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42,